Welcome to second level module B, teaching fractions. So the aim of this video is for us to develop an understanding of the natural progression of teaching fractions. We need to understand the links between fractions and multiplication and division facts. And in this video, we'll aim to understand how to use the concrete pictorial abstract approach when teaching fractions. So in this slide, we're recapping our first level experiences and outcomes. Now there is a first level video tutorial on this. There's 3 separate videos that are all about fractions, and that's an awful lot for us to look at. But when we're teaching second level, we do have to have an understanding of what experiences our learners have had at first level. So from this slide you can see that the main point is that for first level experience should have been that they have explored fractions. They've explored how to create fractions by taking part in practical activities, and by taking part in practical activities they can show their understanding of how you can share an item, how you can group an item, and how we can create fractions, and how do they know about fractions as numbers where they lie on a number line. And it's taking part in these practical activities. They can then move forward to starting to develop the pictorial aspect of their understanding. So just being able to draw a quick sketch to aid their understanding of fractions and demonstrate their understanding of equivalent fractions. So with that in mind, let's have a look then at the first level benchmarks. Again, just give us a recap on what is the prior knowledge of our pupils. Where should they be? So they should understand then how to create fractions. And again, the benchmarks, it says using concrete materials, pictorial representations, and the appropriate language associated with that. That's even before the abstract, and the abstract is just when we're talking about the numbers. When we teach fractions just as numbers, it is an abstract process for our learners. It's so much easier if they can play with manipulatives, their concrete materials, before they can then draw out what a fraction looks like, which aids understanding of what a half actually is. To know that a quarter is half of a half, that 2 quarters are the same as a half, is equivalent to a half, and it's how you start with the basic language and then it progresses into something more sophisticated and more mathematical on it. So they should have been able to compare the size of fractions and place simple fractions in order on a number line. Now that's the big benchmark that I feel wasn't really covered in 5 to 14. It wasn't something I was really aware of at the time, and it's the one that's often missed out in accounting for excellence. This is for you to understand where their prior knowledge should be and for you to plug any gaps in their knowledge. Let's have a look at our second level experiences and outcomes. So at second level, we're starting off saying that I have investigated the everyday context in which simple fractions, percentages, or decimal fractions are used. And from that experience, I can carry out the necessary calculations to solve related problems. So I decide for myself, from the problem solving skills that I have developed, am I adding, subtracting, multiplying, dividing? Am I going to do that with fractions? Or am I doing that with percentages? Or am I converting my percentages to fractions or to a decimal fraction? So it's really important at second level to develop a fluency between fractions, decimal fractions, and percentages. Again, it's problem solving context, and we see that when we move on. I can show the equivalent forms of simple fractions, decimal fractions, and percentages. So again, all grouped together. And I can choose my preferred form. So that's the outcome. The experience was when solving a problem, explaining my choice of method. So at all points in times, we're trying to put our work into problem-solving context, preferably an everyday context, giving them the chance to investigate for themselves. They're investigating, they're playing about, and part of that will be using concrete resources and pictorial representations. And lastly, I have investigated, again that word investigate, I have investigated how a set of equivalent fractions can be created. Understanding the meaning of simplest form. So we're not just telling them that fractions are equivalent. And how do we ascribe the simplest form to them as well? We're asking them to investigate and discover that as they're moving forward in their knowledge. And from that experience, I can apply my knowledge to compare and order the most commonly used fractions. Again, putting our fractions on a number line, but we're now looking at equivalency as well. So the aim of this video is to give you ideas on how you can move this forward and teach fractions in your classroom. Now we're planning for the experience on our benchmarks, because our benchmarks are our assessment standard. Now the ones in red are the ones that I'm going to look at today. We're only going to look at fractions because it's too lengthy to do fractions, decimals, percentages all at once. So we'll look at fractions. If we don't understand fractions, then we're going to discover that percentages and decimal fractions are really, really tricky. So from today's benchmarks, it says here, can calculate simple fractions of a quantity and uses this knowledge to solve problems. Again, problem solving is coming in hard here. I can create equivalent fractions and use my knowledge to put a set of commonly used fractions in order. That's just a repetition of what the experience and outcomes were, wasn't it? And again, expressing fractions in their simplest form. That's the benchmarks for as our assessment standards. The other ones are all about percentages, and we'll come back to that in our next video. Now, just keeping an eye on it, I'm keeping an eye on third level experiences and outcomes. Now, when I first saw this many years ago, it kind of caused controversy in my staff room. And I wonder why. Can you ever read at that and think about what was it that caused controversy, do you think? So third level experiences, I can solve problems by carrying out calculations with a wide range of fractions, decimal fractions and percentages, using my answer to make comparisons and informed choices of real life situations. That's just a bit more sophisticated from second level, not a lot in that, okay? Still get everyday examples, real life situations, problem solving coming through fast here. And by applying my knowledge of equivalent fractions and common multiples, I can add and subtract commonly used fractions. And having used practical, pictorial and written methods to develop my understanding, I can convert between whole or mixed numbers and fractions. Now, why this caused controversy was that this was the first time we actually see anywhere in Credit for Excellence this idea of adding and subtracting fractions of mixed numbers as well. And a lot of our primary colleagues had said, well, wait a minute, but we do that. We do that at primary school. Is this suggesting that we don't see that to third level? And a lot of our pupils won't see third level till they go up to secondary school. My answer to that is absolutely not. You cannot problem solve if you don't add or subtract fractions. Okay, you won't get a deep understanding of what fractions are if you haven't added and subtracted them. You won't get what part of a whole looks like. You know, you have to be able to add them up. Two halves make one whole. Of course you do. And all through the first level videos, I've explained that in great depth. We have to give them an intuitive understanding of mixed numbers. That if I have got what 1/2 plus 1/2 is a whole pizza. If I've got 3 half pizzas, I've got 1.5 pizzas. So from actually playing with that, and I'll show you that when we're counting fractions, they'll have a deep understanding of that from first level through second level. And all we're saying here is we're actually formalising it when we get into third level, and that's when it becomes an assessment standard at third level. But we really need to be showing them addition, subtraction, through problem solving, improper fractions, mixed numbers from a very young age. So by the time they get to high school, secondary school and get up to that assessment standard, it's not going to faze them. They're going to understand what we're talking about. Okay, what are fractions? Okay, well, fractions are many, many things, and we don't always stop and think about it. So fractions can be parts of a shape. Now, sometimes some books call that the area model. Okay, fractions are parts of a quantity. It's sometimes called the set model. Now, I'm not a big one for terminology. This comes from the Number Talks books, and I'm just introducing it to you. I like to keep my terminology as basic as possible. But we know that fractions are parts of shapes, so why aren't we putting it through our geometry? We know fractions are parts of a quantity. They're parts of numbers themselves. They're sharing and grouping. We understand that from first level. Fractions are also numbers. Okay, they're numbers in their own right. They're numbers less than 1. Then there can also be numbers more than one, and I think that's also a misconception we have for our learners. We forget about that. So where do they fit in a number line? So we'll start with numbers between 0 and 1, and then we can extend that larger than 1 and so forth, and we'll discuss that as we go through this video. Now, fractions are also parts of other fractions. This really impressed me the first time I saw it. It's not something I ever taught with, and I did come across this in the number talks books for fractions, decimals and percentages. But it's a real power when we think of partitioning fractions and regrouping them to make different fractions in different numbers, and that'll be the last part in this slide. Very powerful. Now, we're used to doing it with whole numbers, so let's extend into fractions as well. It's another skill for our learners. So it's an example of a fraction talk or a number talk with fractions. Now the question usually is, as a starter, what do you see and how do you see it? And we give our pupils time to think about it, to discuss their reasoning. That way they're going to become more confident mathematicians. I've asked them here to write down as many number facts as you can from this picture. So it's time for me to pause and for you to have a think. Then we can take a screenshot and you can show it to your colleagues and have a discussion about this. What do you see? How do you see it? Write down as many number facts as you can for this picture. Right, I'll come back in a little minute and we can discuss this further. Welcome back. So this is a bit of a drawback when we're doing online learning through videos, isn't it? Because we can't have these discussions together. Now that's why it's really important that you come along to our online question and answer session that's been scheduled for you so that we can actually discuss our misconceptions. If you can't wait, then please go onto our team and ask a question, open up a discussion channel and get talking with your colleagues that are also undertaking this professional development course. So I'm going to just give you some examples to get us going of what discussions I've had in the past when I've tried this with pupils and with teachers. So what do you see and how do you see it? Now on a basic level, we'll have pupils that will just come out with things like, well, I can see 16 squares. No, I can't. I can see 12 squares. How silly. I can see 12 squares. 4, 8, 12. 4 3s are 12. And that's your area model. This is where this comes from, an area model. So they see the rectangle, 3 equal rows. Each row's got 4 on it. Okay, so 3 4s are 12. Some might say, well, no, I see it in columns, and I can see that I've got 4 groups of 3. 4 3s are 12. Okay, and it's up to you then to question that. Okay, and start to bring in this idea of fractions if you want. We have some pupils that will come up and say, well, I can see 4 yellow squares, 2 2s are 4. Oh, there's also a square's red, 2 2s are 4, but the red ones and the yellow ones are together. Okay, so you can say, well, what fraction of this shape is coloured red? Okay, what fraction is coloured yellow? What fraction of this shape is coloured blue? Now, where do you think they'll go with this one? Where did you go with it? Very often what will happen, which is the way textbooks have trained our learners to think, is they'll go, well, that green one, there's one green one, there's 1 out of 12, so the green one must be a 12. Nothing wrong with that, but then they'll move that forward and say, well, if one box is a 12, then the red is 4 12s, the yellow's 4 12s, the blue's 3 12s. And again, it's how do you simplify the fractions? Now, if you give this out actually as concrete materials, this is the power of concrete materials, what happens then with the fraction tiles is that I can rearrange them. It makes it more visual for them. So here's an example of what I mean. If you rearrange, so we're expanding the yellow and the red away from their little squares into rows. Now it's easier to see, isn't it? It's easier to see then that the red fraction is a third. The yellow fraction is a third. So now we're actually identifying that 4 12ths is equivalent to 1/3. Well, what's the blue one then? Okay, well, I've now got at the top there, you've actually got 3 12ths plus 1 12th equals 4 12ths. Okay, but what fraction is the blue? Do they know that? Again, rearrange to help aid on. Now I can see it. Now I can see the blue is actually a quarter. So 3 12ths is the same as a quarter. And again, the other ones can make funny little geometric patterns with it. So it's just really a way of showing you how cognitive materials can be manipulated to make their thinking visible, to aid understanding. And here we're now working with the equivalent fractions. We can now see that 3/12 equals a quarter. This is just an example then of some questions you can ask to really aid higher order thinking. So can you find all other sections that are the same size as, okay, can you find all sections that represent? So again, you know, you could tell them, okay, you could tell them that the red one equals a third, which other one equals a third. Okay, and then it gets about shading fractions. So there's lots in that, depending on what activity you've given them, but just a couple of ideas for you from that. Now, where that comes from the Fraction Talks website. Now, these are great to follow on Twitter. But on the website, there's lots of classroom resources, there's lots of printables for you, and there's lots of photographs and activities, and they come under the different formats here: squares, triangles, actual physical manipulatives, like that tangram there. They're really good, those ones. Different shaped polygons, miscellaneous, and then the photographs in real life context. That's really good as well. You can print them out, they can colour them in, but it's usually asked questions like, so that's square. If the large square equals 1, then find out the fraction of all the shaded areas. Okay, and it's breaking it down into small parts. It's very, very good to do this with pattern blocks if you've got them, and actually recreating what they see with the pattern blocks, which is very similar to their tangrams as well. If you haven't seen this website before, there's a little advert for you, and I'd like you, as part of your homework then, to take time to go and investigate this. How could you use it in a classroom as well? If you do try it, then please can you show us that in your learning log online in your Teams, and come back and give some feedback. Share good practice. We've got a section on the Teams for that. Come and show us your photographs and give me your comments back from what your pupils are saying about these activities. Do you like them? Do you not like them? They find them easy. They will find them challenging, but as part of the challenge, they actually like. They like this investigation, investigating what fractions actually are. And this is when it comes to parts of a shape. So fractions of shapes. Okay, how many other ways can you create 1/4? Now, this is the usual one we'll see in textbooks. So in picture A here, you'll see our square that we had before. It's been halved and halved again. It's been cut into quarters. 1/4 has been shaded red, and you'll see that in the textbooks. Shade 1, what fraction of the shape do you have? So 1 out of 4 has been coloured. So that red square represents 1/4. And then bring the notation there, 1/4. Now, please don't say 1/4. Please always refer to this as a quarter. Okay, it's been one whole shape cut into 4 equal shapes. Okay, so that's 1/4. But how many other ways can we create 1/4? Is that it? Right, want to extend our learning, think about it. So B, C, and D, do they also show a quarter of a shape has been coloured red? And again, if you go onto the resources page on the Teams class notebook, there'll be fraction tiles. These are coloured little squares that you can actually create these shapes, get children to move about. Colouring in shapes are great, but if children don't see it, okay, and can't in their head imagine these shapes moving, it's very difficult for them to understand fractions. So give them the fraction tiles and let them play with it. Okay, so it's coloured square fraction tiles I've got in the resources section. So yes, B, C, and D are all showing 1/4 of that shape has been coloured red. Now again, bring in your fraction stories. For picture A, we could say 1/4 of 4 equals 1. So it's really a fraction of a quantity are linked now with our shapes. For B, C, and D, we can say that 1/4 of 8 equals 2. Moving on then, 1/4 of 12 equals 3, and 1/4 of 16 equals 4. And now we're starting to bring in a little bit of art into this as well. So that's another area we can bundle all this together as well. So we've got art coming in, and the squares just get bigger and bigger, or slightly different. You can ask them to create symmetrical shapes with our geometric art. So I'll show you an activity where you can really extend this. So a geometric art activity. So as I said, using square tiles, again, you can print them, laminate them and cut them up, or you can use cubes or counters. We're asking our learners to create their own picture. Okay, so I'm going to ask you to do it. I'm going to ask you to pause the video, have a look at this investigation. Now you'll see it's kind of differentiated, so we start off really basic, just working in two colours and our simple fractions. Although, as I've shown you, it doesn't always have to be just 2 squares or 4 squares. It can be as big as you like, it can be as complicated as you like, and it can be artistically as interesting as you like. You can move on to 3 colours and 4 colours, and there's different fractions there. Now usually when I do this, we ask our teachers to work in groups, record all the different designs, take a photograph. So I'm going to ask you to do that. Can you upload it onto our team page in our sharing good practice section? Come on, go on, be a show off. Show us what you can do. Or maybe try this with a class of your pupils. See what they can do. I always find each time I do this that either the teachers or the children will always amaze me. They'll come out with the most amazing designs, okay, showing their cognitive fractions. Now you could put limitations on this. You could say everyone's only getting a maximum of 12 or 16 tiles or cubes, because you're probably going to run out of resources. You might also want to state to them, you know, your picture must be symmetrical. Your picture must be a square. Whatever you want to put on it, then that's up to you. But you can put restrictions. Sometimes when you put restrictions, just be aware that it actually makes the investigation more complicated for pupils, but it also makes them think harder. Okay, so have a go, inspire others, upload your pictures onto our page, and we can all start liking and making comments about it. So pause, have a go. Now when you come back, we'll try something different. Now let's move on and look at fractions of a quantity. Okay, now what we're thinking is here, how can we use this with concrete materials? Now the point in using the concrete materials is to aid understanding. We want to develop a deep conceptual understanding of what we're asking in these calculations. So the question says, what is 3/5 of 65? Now, when we just see the numbers like that, now hopefully you'll put that in a problem solving context, but for just now, we're just looking at how do we actually use concrete materials to solve that problem. 3/5 of 65. Now, children who have been taught processes and processes only, usually the first thing they'll say to me is, oh, miss, I can't remember, do I divide by the top and multiply by the bottom, or is it the other way around? So they know there's divided and multiplying going on, but they don't understand why they're doing these processes. So concrete materials will help them make that thinking visible for them. Now 65 is a larger number than we used to are working with, and in the first level they'll be looking at smaller numbers, but we're still not getting out 65 buttons or 65 counters. So what we can use is we can use our place value counters, and we can count out 65 and start thinking, well, I'm going to share £65. Okay. What would 3/5 of £65 be? Well, the first way you're thinking of is, well, really, what's 1/5 going to look like? Now here, let's look at the bar model. I've got 65 written down, and then below that, I have got 5 sharing grids. Basically, that's what that is, right? We're moving away from circles, we're sharing circles. We're trying to get this idea now of the bar model, but it's just 5 areas we can share into. And they can start sharing out their counters. So they share out their 10s. Okay, share out their 1s is what they'll want to do, and then they'll have this 10 left over. Okay, so they've shared out here their 55 and they've got 10 left over. And at that point, hopefully they'll understand that 10 divided by 5 is 2. Okay, and they can just write down 2 underneath, or they might want to exchange. Now remember, the whole point in doing this is to take children who are really struggling with their maths and helping them to keep up with their peers, okay, by giving them the resources they require. Right? So they might want to then break down that 10 into 10 ones and then share it out. So then we can see that 65 divided by 5, 1/5 of 65 is 13. Linking again our division facts and our multiplying facts as well, okay, with that one. If your children are struggling with dividing, then they're going to struggle with fractions of a quantity because they're just division calculations. And then you might have to assess, well, actually, why can't they divide? Is it because they don't have a firm understanding of multiplication? So you might have to unpick this a little bit. But when giving them the resources, you kind of find that they can work out the answer. So by taking their 65 counters and actually physically sharing it, they're doing the dividing action. You're embedding what division actually is. And now I'd encourage them to write down, well, what actual maths facts do I have here? What number facts do I have? So I first of all have a fifth of 65 equals 13. Again, noting with them that's the same as 65 divided by 5. Well, what would 2/5 be? 1/5, one group is 13. Well, two groups, double 13 to get 26. Well, what would three groups be? 13 times 3 is 39. And if they have to count them out in repeated addition, 13, add on 13 is 26, add on another 13 is 39. So you're embedding repeated addition is the same as multiplying. And the inverse properties of multiplying and dividing is very important. Okay, so step by step, 1/5, 2/5, 3/5. One lot's 13, two lots is 26, three lots is 39. And what are these lots? Which are these pieces? These pieces happen to be called fifths. It's the name we give to them because we've got 5 equal portions. That's how we divided up our 65 in the first place. Now, that's a concrete way of describing it. And then we're moving them on slowly until when they feel it's appropriate, that they don't have to play with the concrete resources, they can just draw. So it's a pictorial. And I would go for the bar model when I'm dealing with fractions. And the bar model is a simple rectangle. I'm drawing out a bar. So here I've got my 65. And again, it's the power of understanding how to partition and regroup numbers. So 65 is a tricky number to divide by 5. But if I split that down into a 60 and a 5, or a 50 and a 15, okay, depends on how sophisticated my learners are with their thinking. Okay, so when I'm dividing that by 5, I've understood then that 65 by 5 is 12, 12 and 1 is 13, or 10 5s are 50, and I see that as a 10 and a 3. Okay, both ways I'm going to get the number 13. So 1/5 is 13. I don't want 1/5, I want 3/5. So I can shade it or colour it in. 13, 13, 13, 13, 26, 39. My repeated additions coming through with that one. And I can now actually see that from this visual that 3/5 is larger than the 2/5, but altogether it comes together to be 5/5 is my whole. Got to do that before I move on to the abstract, and the abstract is your usual formal traditional step calculation. And again, if we've been looking at first level division, cell division, if you've looked at that, looked at those videos, you'll have seen that this is how we teach how to divide. That we actually partition the number 65 into two easier numbers, usually within the times tables, okay, called our very important products. And now we've got our 65 as a 50 and a 15. That's usually the 10 times plus whatever's left over is usually the easiest way of doing it for them. Okay, let's try another example then. It's worthwhile you pausing this as well, taking the time to go and get your concrete materials and play along with me as well, or have a go yourself and unpause me. So the next example is going to be 2/3 of 72. Okay, so how can you help your learners to understand how to solve this problem? Right, so pause, have a go yourself, and then come back and we'll look over the answers together. Okay, right, welcome back. Now you've probably gone away with your place value counters as well, and you've used that to share out your 72. Okay, I'm going to show you just the bar model but larger now, so we can have a look at what that looks like. So we've got 72. Now, when you do the bar model, if you've not done this before, we're not looking for rulers or anything, they're just a sketch. Okay, the point is that each bar should be the same size. So it's underneath each other, and that helps us with our logical thinking when we're thinking about algebraic and how to set out our calculations when it comes to equations later on. So I've got my 72 and I think about that number 72. Okay, I'm going to divide into 3 equal portions to find out what 1/3 is going to look like. So to start off then, how can I partition out my 72 into the 3 times table? 3 whats are 72? Now, do your pupils know that 60 is in the 3 times table? Is 6 in the 3 times table? Then 60 should be in the 3 times table. So 60 and a 12, and then thinking, well, I should divide 3 whats are 60, so 3 20s are 60, 3 whats are 12, 3 4s are 12. So your answer would be 24. So again, we find division tricky, then let's not divide, let's think about multiplying. So we've now got 24 as 1/3. So what would 2/3 be? Well, 2/3 would be 48. Let's double check. Does 24 and 48 add together to give me 72? Yep, yes it does. I've got a 16, a 12, I've got a 72 from that. Okay, so partitioning and regrouping is going to aid your division as well as your multiplying and division facts. That's where the aim of this video was coming from today. Now that's your pictorial one. Before you're then looking at the abstract, again, your compact step calculation. Now, if pupils are quite comfortable with their picture, with their bar models, do you have to go to the step calculation? For some, that'll be a step too far. Now, it's just to make you aware then, when you're moving up into secondary school, there's no such rule or regulation that just says that you have to do formal calculations all the time. That's something that teachers are telling our pupils, but it's certainly not an exam standard. Exam standards are just looking to see, have you explained your thinking? Have you used appropriate method? So both ways are appropriate methods here. Okay, so just be aware. We're trying to build resilience in our learners, mathematical mindsets, a growth mindset. Yes, I can do that and I can explain my thinking, my understanding to you. Oh, right, so we're now moving on to look at numbers, fractions as numbers on a number line. Now this was an example from first level, okay, and I can have practical investigation with them. Have they been counting in fractions? You can use your counting stick for that. So the example here is counting in quarters. Can you count in quarters with me? So they should be then used to counting 1/4, 2/4. Now I've got the visual aids here of the pizzas. And you ask yourself, well, I've got 1/4, I've got 2/4. And what I'm saying in first level is I don't want to hear 1/4, 2/4. That's abstract. Okay? It's 1/4, and that's the symbol for 1/4. I've got 2/4. Okay? A quarter is the size of the object I've got. Well, what else have I got? I've actually got a half. So you're starting to discuss equivalent fractions with them, but it's a very natural process. So I've got 1/4, I've got 2/4, I've got half a pizza. I have got 3/4. That's the same as a half plus a quarter. So we are adding fractions. What's missing from a whole pizza? So 1 whole pizza, take away a quarter, equals 3/4. Why? Well, because 4/4 is the same as 1 whole pizza. Okay, so we are adding, subtracting, but you do it in a real life context and you do it problem solving. Okay, I can move forward. I've got 5/4, I've got 1 1/4 pizzas, I've got 6/4, I've got 1 1/2 pizzas, 7/4, and you get the idea, and so on and so forth. It's just a nice way of having a counting activity where you're introducing lots of concepts. Improper fractions. This is at first level we're doing this. Improper fractions. We're doing mixed numbers as well. This idea that we're just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We just happen to be counting in fractions, and this time the fraction is a quarter. Okay, now from first level they'll have been creating quarters. They would know to half and half again a shape or a quantity. They would know that a quarter is half of a half. And building up this deep conceptual understanding of the nature of fractions is really, really important. So we can take that, we can move it forward a level in second level. Okay. We're now looking at our number lines. And how often have we done this in the past? I know myself, I very, very rarely did this. But it's a nice for a starter activity to gauge understanding, to look for misconceptions in their understanding and their knowledge of maths. So this number line I got from a website called mathspot.com. It's fabulous. Okay. They create them for you. I took a screenshot. You can make up your own activities, your own worksheets, or you just like I've done, put it in a PowerPoint and have it as a starter activity. So that activity could be fill in the missing numbers. So hopefully they've understood from first level that half of a half is a quarter and that two halves make a whole. Okay, so we've got half of a half's a quarter, so then counting 1 quarter, 2 quarters, 3 quarters, 4 quarters, and 4 quarters makes a whole. And when they see the numerator and denominator being equal, that's when they know they've got a whole. That's just 4 divided by 4. 4 divided by 4 equals 1. Okay, they're also then counting in halves. Hopefully they've understood then that 1 half, 2 halves, and 2 halves also equals 1. So they've got lots of equivalency going on here and actually understood. 1 half's the same as 2 quarters, 2 halves the same as 4 quarters is the same as 1 whole. And which one is the simplest form? And having that discussion with them, that it's the one with the least number of pieces, or the largest piece would be the simplest form. Now, you can tell on MathSpot how many divisions you want it broken up into, how complicated do you want it. The reason I'm discussing this is because we're working in families of numbers, families of fractions. So when they're learning their times tables, they'll learn the 2 times table and the 4 times table. It's their doubling and halving, doubling and halving. They then go 2, 4, they'll look at 3, 6, but then they'll go 2, 4, 8. So we do the same with fractions. We've got halves and quarters, and how are they linked? That a quarter is half of a half. Well, what's half of a quarter? And again, when you see the number line there, they might actually have to count up. Well, how many pieces have I got in my number line? Right, I've got 8 pieces. So that means one piece is called 1/8. So I've got 1/8 is half of a quarter. And they might want to count up 1/8, 2/8. Oh, that's the same. That's equivalent to 1 quarter, 3/8, 4/8. That's the same as a half. So now a half can be many things. A half can be 2 quarters and it can be 4/8. 5 quarters, 6 quarters, 5/8, 6/8. And again, we've now got 6/8 is the same as 3 quarters. It's equivalent to 7/8 and 8/8. And again, we'll make that connection between 2 halves, 4 quarters, and 8/8. Numerator and denominator are the same, they're equal. Therefore, we have 1 whole. Now, when you're looking at numerator and denominator and the roles of the two, I tend to like to think that the numerator is how many pieces do I have, and the denominator is really telling me something about the size of your piece. They understand if I split something into 2 pieces, that's going to be a larger piece than if I split it into 4 pieces and I've got my quarters. Okay, quarters are larger than dividing something into 8 equal pieces. And it's having that rich discussion at first level and understanding of the relationship between halves, then quarters, then eighths. Now, once you've got that idea, they're quite happy with that one, then they should be able to move forward to the next family. So this is my next family, okay? And when you show you this number line, what do you think learners are going to do? Okay, quite tricky. So it tends to be from normal practice, they'll go back and start counting, well, how many pieces do I have? I've got divisions starting from 0, jumping 1, 2, 3, 4, 5, 6 pieces to get up to 1. So each piece is going to be a sixth. And again, counting 1/6, 2/6, 3/6. They'll start to see that equivalence is coming in here, that 2/6 is the same as 1/3, that 3/6 is the same as 1/2. And again, you start adding then, you start thinking, well, 1/3 plus 1/6 equals a half. And why is that? Because it's 2/6 plus 3/6 equals a half. And again, this will be easier to understand when we look at actual fraction tiles. This is just ordering numbers, just then get this concept of actually counting. And so forth, like up to 6/6 equals 1. If they're counting in sixths, well, can they fill in counting in thirds? So a third is 2 sections. So that'd be 1/3, 2/3, 3/3. That's a family in itself. Okay, so we've got 2, 4, 8, and we've got 3 and 6. And again, if you're teaching a times table, they should have been taught the 3 times table and then the 6 times table, again for the doubling and halving of numbers. Very, very important that we embed that with them. So if you haven't seen the other videos, really when you're doing your times tables, they'll skip count, repeated addition. From early level, they'll do skip counting in 2s, then 5s, then 10s. So that's them got the 2, 5 and 10 times table. They'll then go back and look at the 2 and 4 times table and then reinforce the 5 and 10. And then they go back and look at 3 and 6, reinforcing the 5 and 10, and then 2, 4, 8, then 3, 6, and so on and so forth. And how to link in the 9 and the 12 is a whole other video. So we're back to counting fractions on a number line. So they've got the thirds and the sixths going on. And then we're looking at this type of idea. So my goodness, we've started to bring in, what have I brought in now? I brought in 12s. I can see 7 12s. So I'm now mixing it up. Oh crikey, this is really high order here. Halves, quarters, thirds, 12s. And I wonder what else is in among here. So it's worthwhile stopping and trying this yourself. Okay. What learning points are we going to be looking at with our learners? Why will they find this tricky, and how are we going to aid them to make it simpler for them as well? Okay. So have a think and come back. We'll have a coffee. This is a long video today. Have a coffee, come back, and we'll have a wee discussion round about it. Welcome back. So what was the first thing you tried with this one, and what are you trying, what are pupils trying, and what are we hoping they're going to try? Okay. Now, by looking at what they do, you'll be able to assess how deep their understanding is with this one. Right? Some pupils will just go and just counting all the 12s. Okay. And that means they've got quite a lot of it filled in, which is fine. But they're pushing them forward, looking for how to count in halves, how to count in quarters, how to count in thirds. So first up, what did I do? Well, I started with my quarter. I then thought, well, that's 2 quarters there. So 3 sections is 1 quarter. Another 3 sections, half is 2 quarters. Another 3 sections to get my 3 quarters and my 4 quarters. Like I did in my quarters. Okay. Thirds, bit of a leap of faith here. Okay. Now, how did I find that that was a third? Well, what I did was I went from half of 2/3. Okay, so I counted 1, 2, 3, 4, 5, 6, 7, 8. 8 sections was 2/3, half that to find 3/3. Right, and I understand that's really quite high up there, but 1/3, 2/3, and 3/3 got in my thirds. Okay, but this is probably what somebody would have done in the first place. 12s, 1 12, 2 12s, 3 12s, 4 12s, and so forward. And again, having that discussion then about equivalence. Now, if this is done as a group activity, you'll get the children with a lower level of understanding will have done all the 12s. And then have that discussion with their peers in a mixed ability group about, well, look, 3 12s is the same as a quarter, 4 12s is the same as a third. Can they make the connections there? Okay, if I divide 4 into 12 sections, I'm going to have 3 times as many pieces. And then 6 12s is the same as a half, same as 2 quarters, and the connections between that. Well, 6 is half of 12, 2 is half of 4, 1's half of 2. So they see this, why is it called halves then? 8 12s, same as 2/3, 9 12s, and again, well, is it double? So 1/3's 4 bits, 4 12s, 2/3 is 8 12s, so linking the 4 and the 8 12s together. Then we have 12 12s, so again, linking that when the numerator and denominator are equal, the same size, then you have one whole. You can also be looking to see, well, what bright sparks? Notice that we can start filling in more. We can fill in sixths. Do they know then a sixth is a half of a third, but it's also double a 12? A lot going on in there, right? And now we're bringing the idea that 12s have brought together my families. They've brought together the halves, quarters, and they're bringing together the thirds and the sixths, right? So I've got 1 sixth, 2 sixths, 3 sixths. So lots of equivalency, really rich discussions coming in here for you. So just an example. Now, moving forward with you can extend numbers beyond 1. Okay, Extend and challenge your learners. How they're going to cope with this one. Okay? And you can give them some tips. Well, I'm still hoping they know that half of 1 is a half. Okay, can they count in their quarters? Well, that'll be 2, that'll be 3, the last one's going to be 4. And then filling in all the separate sections with you. And I'm going to leave that one with you. I don't think I've kind of put in a couple of ones. Oh, count, yeah. The reason I've done that then is counting up in the halves. 1 half, 2 halves, 3 halves, 1 and a half, 4 halves, 2. Okay, linking in. So we're now seeing improper fractions, mixed numbers all coming. Is it creeping into third level? Is it still second level? It's a third level assessment, but that'll really help you see your understanding of your pupils. Okay, 2 halves, 3 halves, and so on. Now on MathSpot, you can actually ask it for mixed numbers, simplified forms, and you can also bring in decimals with it. So you can really push this on up to a high level and really challenge your most able learners with this one. So it's really worth getting onto MathSpot. So homework, get onto MathSpot and play about with this. So you can see at the top there, begin at. So you tell it what you want, to begin at 0, to begin at 2. You can, if you want, do negative fractions. Okay, negative numbers come in here. You then tell it how many partitions you want. Are you working eighths here? You then reveal it as many as you like, from 100% down to 10% and so on. And if you don't like what you see, you just keep hitting that refresh button. And again, you decide you want to partition the numbers. That means into your mixed numbers. You can have decimals going on, you can have fractions going on as well. Right? Do you want it simplified or not? So it's really, really useful. I can't tell you how much I love this as a teaching resource. Okay, so homework, go off and have a play, come back onto Teams, let me know how you get on with it, share best practice, good practice with your colleagues on the course as well, and show off how much your pupils are liking this. Don't worry, I appreciate you might be doing this as training and it's not actually the topic you're doing in class right now. You might want to try it as a bit of a starter activity with your class. Maybe you're going to do refreshing what you think they should already know, right? Assess their prior knowledge from last year, okay? And have a discussion about that as well. It's always useful to do that as you're moving along. Okay, right, more activities then. Right, ordering fractions using tiles. Okay, this is us getting them to order which fraction is the largest, which is the smallest. They can't do this if they've not been counting in fractions, right? So they can't do their times tables if they haven't done repeated addition, counting forwards and counting backwards. If they can't count backwards, they can't divide. So the same happens with fractions, right? So don't panic, I'm going to show this again. But before I show you this again, I'm going to show you what tiles you've got. So as part of our team's, you can either print off and cut up the fraction tiles I've given you, or why don't you make your own fraction tiles? Now, this is an activity I normally would have done if I saw you in person, but I gave you strips of paper. Now, I used A4 paper, landscape, cut up into strips. You'll need at least 12 strips. And usually the challenge was to make your own fraction wall by working in these fraction families. Now, it's something really worthwhile to do for your class. The power of actually physically halving a piece of paper to make a half, and then halving again to make a quarter, is really powerful for embedding the link between halves and quarters. And half, and half again to make eighths. And how do I make 12ths? Okay, this brings up a whole pile of misconceptions when you do this with pupils and sometimes with teachers. So it's a really worthwhile activity to do. So you can either pause and try that, or you can go and print off your own fraction tiles. But I really want you to do that, okay, because this is going to help you problem solving for the rest of this video. So go off and do that, come back, and then we're going to do the ordering the fractions activity. I'm going to go back to that, and then you're going to do a whole pile of problem solving, adding, subtracting fractions in everyday context using your tiles. And the idea behind all that is, does it make your thinking more visible? Does it aid understanding? Okay. Will it make fraction work more accessible to children who are really struggling with their maths? Right, look forward to seeing you back again soon. Now, I should have also said then that if you didn't have that fraction, MathSpot has also got online fraction walls, especially in the times we're having just now, where if you're working online, you can use this facility as well, and you decide from the denominator there in the top right of the page there, what size of fractions you're actually going to need for your problems. Okay, that's something else you can be using if you've not got your own fraction tiles. Here we go. Ordering fractions, time to pause me again. Now, this was just taken off a website as well. I think it was taken off of Mr. Barton Maths. What's the largest? What's the smallest? Can you order them? What misconceptions are we looking for? Why do children find this really difficult? Okay. Why is it they think that big numbers mean the fraction's big? Because they do. That is a problem they've got. Okay. And again, what do we mean by 2/3, 3/4? And again, use that language. Please don't teach 1/2, 2/3, 3/4. Okay. They have to physically understand what a third looks like and feels like, and what does 2/3 then look like. I have two pieces, each piece is a third, and this will help them do that. So I've had enough of talking. Pause me, have a play. This is something we'll discuss at one of our live Q&A sessions. Okay, let's have a look at problem solving with fraction tiles. Okay, so here are 4 separate examples for you. Again, pause me, I'm going off for another coffee, and have a go with this one. Right now, when you open up your fraction tiles, do me a favour, don't just build up a fraction wall. I want you to think about the actions of these problems. Okay, so for the first one, for example, so you give a third of a box of brownies to Ella. So think about getting a third and giving it to somebody. You then give a sixth to Nick. So if you give away a third and a sixth, you've got 2 tiles in your hands. How much have you given away? What's the overall size? What's a third plus a sixth? Okay, comparing it with other fractions in your little bag. Okay, have a go, come back, and I will go over the answers with you. I've got it all animated for you. Right, see you again soon. Okay, so here goes. So you give a third of a box of brownies to Ella and a sixth of the box to Nick. How much of the box of brownies did you give away? Now, what I didn't tell you before was it's sometimes useful, it's always useful, to compare to your one whole box. So that's my box of brownies. I've got my third and I've got my sixth. So altogether, how much of the box did I give away? So really what we're saying is, what's a third plus a sixth? Now, just physically looking at it, what do you think the answer would be? So this visual power comes into play here. Most people straight away go the same as a half. So just double check, compare underneath, triple check, compare at the sides. Yep, it looks like a third plus a sixth equals a half. Job done, I've got the answer. But you want to investigate further with your pupils. How is this working? Okay, because they can't keep memorising all these sums. Well, what they'll then realise is, well, wait a minute, from my counting strategies, I know that a third is the same as 2/6, and I can show you that with my fraction tiles. So if I've got 2/6, add on 1/6, I've got 3/6. 3/6 is the same as 1/2. And that's what we're hoping for. If you'd been teaching that traditionally, you would have said to them things like, well, you can't add thirds and sixths together because they're not the same size. So you'd have to convert your thirds to sixths. So how do you do that? Well, you multiply top and bottom by 2, and you'd have all that story. Well, you're not multiplying top and bottom by 2. You're halving the thirds to get sixths. Right, when you multiply denominator, you're actually halving. Okay, so you're halving the thirds to get 6, and I've got twice as many. Multiplying by 2 comes into play. Right, those type of discussions are coming in. Right, let's look at the next. So James went for a long walk. He walked 3/4 of a mile and then sat down to take a rest. Right, so you're grabbing your 3/4. Then he walked 1/8 of a mile. So how far did he walk altogether? So again, I'm adding these fractions together. So I've got my whole walk. Well, it's a whole mile, isn't it, really? Now this one actually could be tricky, because how do I know it's going to be less than a mile? It might not be. And that's fine. So I write visual aid, you'll see, for this one. So I've got my 3/4, I add on my 1/8. Oh, whew, right, it's less than 1 mile. Right, could have been more than 1 mile, but don't worry about that. So I've got 3/4 add on an 1/8. Well, what is that altogether? Now, you'll see some pupils will do the following. They'll just work out what's the bit that's left over. Some children know straight away an 1/8 is left over because they know that an 1/8 is half a quarter. Some will do trial and error with this one. So an 1/8 left over, that means everything else must be 7/8. And again, just reinforcing that, you can put the tiles underneath to make sure it's 2, 4, 6, 7/8, because 1/4 is the same as 2/8. So Liam and Sam shared a chocolate bar. Liam ate 3/5 and Sam ate 4/10. Who ate more and how much more? Now this was a lovely one for really assessing deep understanding with our pupils. Okay, you could just change that. Now I just got this from a test worksheet and I've shared that on the Teams page for you, but you can adapt it. If I could have written down there, Liam and Sam shared a chocolate bar. Liam ate 3/5 and Sam ate the rest. Who ate the most and how much more? Your pupils should be able to solve that problem. They should know that 3/5 is more than half of 5/5, so Liam ate more. And if Liam ate 3/5, how much was left over of 5/5? 2/5 was left over. So they'll now know that Sam ate 4/10 is the same as 2/5. Right, so let's make that visual. So what's going on in there? Now that only works if they've understood that the whole is 5/5 in the first place. Right? So that's my whole chocolate bar. Liam ate 3/5. Well, it's more than a half, so he ate the most. What's left over? Okay. You can also see that 2/5 is the same as 4/10. And we can see our 2/5 coming in there. Okay. So did I say that? 4/5. What did I say there? 4/10 is the same as 2/5, right? And that's the same as what was left over. That's right. Okay. And this is very much the comparison bar model we're showing here when we're comparing two separate sections. So the first stage I was comparing my 3/5 and my 4/10, and the 3/5 we can see is more than the 4/10. So Amy ran 2/3 of a marathon, Beth ran 5/6 of a marathon. Who ran further? How much further? So again, this comparison model. That's my marathon, my whole marathon. Amy ran 2/3 of it. Beth ran 5/6. Who ran further? Beth ran further. How much further? Oops, 1/6 further. And you can now see that 1/3 is 2/6, 2/3 is 4/6, 4/6 is less than 5/6. How much less? 1/6 less. It's a time to challenge yourself now, right? Now, when you do this with the tiles, start thinking about how would you normally do that, right? If you didn't have tiles, if you were just using an abstract number system, right? So half of the pupils in a school have blue eyes, 1/3 of the pupils have green eyes, the rest of the pupils have brown eyes. This just came from a very common textbook. Okay, how many pupils are in the school if 40 have brown eyes? Now, when you give that to pupils in a class, normally they get to the second sentence and they give up the ghost, right? Oh, the problem's, oh no, it's too hard and I can't do it, and they start whinging at you. So have a go with the tiles, have a go with your normal thinking, see which is easier. Okay, come back and I'll go for the answer. So let's have a look. That's my school. Half have got blue eyes, 1/3 have green eyes, the rest have brown eyes. Just by playing about, I can work out that's a 6th. Okay, but I have to play about to discover that. So, how many pupils in the school if 40 have brown eyes? So now I know that a 6th equals 40. So what's the rest going to be? Well, the rest is going to be 5/6, isn't it? So 1/6 is 40, 5, sorry, 6 are the whole school. I've got 5 6 left over. Okay, so I've got 6 times 40 is 240 are in the school. You can then extend this is what I was thinking about, and saying, well, how many don't have brown eyes? That would be your 5 6, that's what I was thinking of. Or you can say, how many have green eyes? How many have blue eyes? Do they all add together? Give them my 240 pupils. There's lots going on here, lots of ways of thinking of extending your problems, looking for deeper understanding, right? Challenging your learners. Right, even more advanced. So far we've been working in fraction families. We worked in thirds and sixths, we worked in quarters and halves and quarters, okay? So now I'm looking at denominators where they're not multiples of each other. That's where it becomes a lot more advanced. So Billy made 2 types of cookies. He used 2/3 of a cup of sugar for one recipe and 1/4 of a cup of sugar for the other recipe. So thirds and quarters. So I'm going to have to deal with equivalent fractions. How much sugar in cups did he use in total? Okay. So again, pause and have a play with this one, because this is one you've not seen before, I don't think. Right, time for the answers. So I've got my whole cups of sugar, I've got my 2/3, and I've got 1/4. Okay, so what would the answer be? And again, you'll find a lot of pupils will just play about with it, and they'll realise that a 12 is the missing link. So then they can sometimes put all their 12s down, and they'll see that 1/3 is 4/12, 1/4 is 3/12. But they'll know if I've got 1/12 in total, then I must have used 11/12 in total. They can also start to see then that I've got 1/4 plus 1/2 equals 1/3. So lots of addition coming in here. So 4/12 is the same as 1/3, and 1/3 is the same as 1/4 plus 12. So there's lots of in-depth maths going along that we're seeing visually here. So thinking again about common denominators and how we're going to teach this. So back to basics, 1/2 equals 2/4. Why is that? Well, we're saying, well, 1/2 of 2 halves equals 2/4. So 1 times 2 is 2, 2 times 2 is 4. So I'm multiplying top and bottom, okay, by 2. I'm just pulling that to the side. I'm actually multiplying by 1, right? 2 over 2 is 1. I'm not changing the overall size. Now, sometimes we have a problem when we say we're multiplying fractions, because people then think we're getting more and more and more and more, right? They're getting bigger and bigger and bigger. The overall quantity is not getting bigger. They're just changing shape, right? Changing size. So we're multiplying by 2 over 2 is the same as multiplying by 1. But what we're saying is we're dividing the half to make quarters. That in turn doubles the number of pieces I've got. So when we're multiplying a denominator, we're actually dividing, right? So we're dividing our halves to make quarters. That's where the 2 times 2 equals 4 comes from. And because I've done that, I have doubled the number of pieces I've got. 1 times 2 is 2. You might want to think about it this way. If I'm going from halves to quarters, well, what's half of 4/4? That'd be 2/4. Another way of thinking about it. But you'll find it's very intuitive, this idea that they've been playing and investigating with their fraction tiles and their pictorial bar model type methodologies. They'll come across this themselves. It's not something we have to worry about teaching. But just don't keep saying we're multiplying. No usual. We can multiply top and bottom by any number we like, right? Well, we can, but why are we doing it, right? So get the actions involved with it. Now, where are we going with this, right? So adding and subtracting fractions is technically third level, right? But this is when it becomes a car crash. So here's a wee chat. 2/3 plus 3/4 equals 5/7, right? Very common answer. So what misconceptions are evident, and how can you address the gaps in this learner's understanding? Now, this is a very common misconception, and I think it arises because we've been teaching fractions from a very abstract point of view as just being numbers. Even worse, when you say, well, what's 2 over 3 plus 3 over 4? And all people will see is, oh, there's an addition symbol there, so I must be adding. So 2 plus 3 equals 5 and 3 plus 4 equals 7. Ta-da! There we go, that's how we add fractions. They've not had the experience of cognitive resources and a deep understanding of what 2/3 actually is. What is 3/4? So how can we help along with that one? Well, here's another thing, right? So let's think about it. What does 2/3 actually look like? Now, post-its are a wonderful thing for doing fractions as well. So purely because they're all the same size, right? So I'll give you a post-it, draw thirds, colour in 2/3. Here's another post-it. Half and half again to make your quarters, shade in 3/4, right? Take another post-it, split up into sevens, 7 equal strips, colour in 5. So looking at it, right, doesn't make sense because you'd think that 2/3 plus 3/4 is obviously going to be more than 1, bigger than 1. Okay, it can't equal 5/7. So how am I going to work this one out? Now, if you superimpose, the reason why I've got the 2/3 vertical and 3/4 horizontal is because you can superimpose, and that's going to help you understand equivalent fractions. Okay. So I've now got my 2/3 is the same as 4 3s are 12, 12ths. So my 2/3 is the same as 2 4 6 8, 8 12ths. My 3/4 is the same as 3 6 9 12ths. So I've now got my 8 12ths and my 9 12ths. I've got my 17 12ths. And that's the same as my 1 and 5 12ths. Now you can see from the left hand side there that I've got 4 light blue squares, okay? So if I take 4 over from the 3/4, my whole is made up and I've got 5 squares left over, okay? My 1 and my 5 12ths. So they can start playing about. It's hard to see it online, and my apologies when I've got this video. It's much easier to do this in person when you're actually playing with the post-its and you can see it. But that's a more visual way of teaching how to add fractions, which we're then moving on to when we're looking at third level. Last but not least, I mentioned before about the power of partitioning and regrouping. Now we do this all the time to help us with addition, subtraction, multiplying, dividing with 4 operations. We're used to doing it, breaking up that number 8. What can it possibly be? Okay, breaking up the number 72 to 8 with our division into a 60 and a 12 when we're doing our multiplying, dividing facts. So how would that look then when we had the same idea when we're talking about fractions? So let's think of this fraction 5/6. Okay. What else could 5/6 be? Right. A physical quantity. What else could it be? So here I'm going to show you what it would look like if we were looking at the bar model. So there we go. That's a bar divided up into 6 equal portions, and I've coloured yellow 5/6. But what else could it be? Well, I know that 3/6 is the same as a half. 2/6 is the same as a third. So 5/6 can also be a half plus a third. So it could. What else could it be? And again, it's just seeing what your learners come back to you with. Okay. Well, actually, now we're talking about thirds. I know that 2/6 is a third. It could be 2/3 plus a sixth. Okay. Now, why are we doing this? Now, the reason I'm doing this is if we can break down a 5/6 into smaller parts, then in third level, when you're given a problem, what is 2/3 plus a sixth? What is a half plus a third? You're more used to then working with your equivalency, okay, to add fractions to make your answer. So here we're starting with the answer and we're just pulling apart and rearranging it, partitioning and regrouping to have this deeper understanding of how fractions are formed. Right, that's us done. What impact, it's been a long session today, I know it has, what impact will this session have on teaching and learning in your classroom? Again, just to highlight, we do have our Twitter feed at CfE Numeracy. Please get involved, give us a follow. If you're doing something in the classroom, you're learning something new, then please share with us and inspire your colleagues. Remember also that we're on the Teams page. You have got your learning journal to keep up to date. That's just really a diary, okay? When were you doing your videos? When did you try your fraction tells and your problem solving? Have you tried anything in class? Have you discussed it with your colleagues? Okay, if you're struggling at all with this, find your maths champion in school ask them for support, and get that discussion going. The more we can have professional dialogue with our colleagues, then the more we can learn from it. Okay. Please also get in touch with myself. You've got my email, karenoppo@easternbartonshire.gov.uk, or you can also, if you write a wee comment, you can ask me on the Teams page, and I will try my best to get back to you as soon as I can. Right. Hopefully you've enjoyed this video. Look forward to the next one when you've got time. It's going to be all about teaching decimals. See you again soon. Thank you.